Okay, welcome back and welcome to Chapter 5. We're still in the analysis phase on this of the SDLC model that the book is taking. So this chapter and the next one are all going to be about how to do logical models of the system. It's not going to get into details on how things are done, but just more of a big picture on how things are all supposed to fit together. Okay, so I'm going to go through the chapter objectives to make sure we've got everything. This is describe data and process modeling concepts, include data flow diagrams, data dictionary, and process descriptions. Describe the symbols used in data flow diagrams and explain their rules. Draw data flow diagrams in a sequence. Explain how to level and balance a data flow diagram. Describe how data dictionary is used and what it contains. And use process description tools such as structured English, decision tables, and decision trees. And describe the relationship between logical and physical models. Okay. As before, that little preview case that starts on page 179 is still pretty doggone cool. So take a minute to read the preview case. And let's start. On on page 180, kind of an overview of where we are. This is the chapter that we're on, the data and process modeling. And they have it broken up into certain chunks, explaining about data flow diagrams, identifying the symbols, describing them, creating dictionaries, and how we're going to show logical processes from there on. Okay, so I guess a good place to start would be the definition of what the heck data flow diagram is all about. Well, I guess we'll back up. Systems analysts use many graphical tools, and the data flow diagram being one of them. There's an awful lot of different tools that are out there. This one is basically trying to show how processes and data interact. That's basically its thing. So, now, the definition. Data flow diagram shows how data moves through an information system, but does not show the programming logic. In other words, it doesn't peek underneath the covers to see how things are happening. That's for another step later. This is a higher altitude approach of just, here's what needs to be done, and we'll figure out how we're going to do it later. So it's a logical model that shows what the system does, but not how it does it. Okay, so we're going to be doing some little diagrams, and the first one they talk about on page 181, there's two different standards you can use for doing these little models, and we're using the Gain and Sarson version. It doesn't really matter which one you use. That's not relevant at all. But on page 181, we're using the one on the left side of the diagram. So there's basically just four symbols, so this is not that complicated. You're starting with a process symbol. So the process symbol in the Gaines and Sarson is a kind of a rounded rectangle. And it's considered, at this case, it's considered like a black box, meaning we really don't know what's happening inside that box because, again, that's to be done later. And so you're just describing a system. And in fact, when we first put this thing together, the entire system is going to fill that one box. And then you're going to be able to zoom in and see more and more and more. So it is just an upper level description of what these things are. So the process symbol, let's just kind of go through it just a little bit. It says you must have at least one input or one output, because if all you have is a process that doesn't talk to anything, then you hardly have a process at all, right? It contains business logic that can transform data, that can work on data. So, it could be a rule. A business process could be an entire system, or it could be a very tiny portion like, do I want to accept this guy's credit card number or not? That kind of thing. And the process name identifies it. That makes sense. And it's often like a function. These are action words. These are verbs. So a process is typically like approve transaction, as an example. or pay bill or something like that. They typically have action verbs in the name. Okay, and they usually start with a number, have a number associated with them, and we're going to talk about this contextual view and the level 0 view. So you start with numbers, and the more detail you get, the higher the number gets. So a level 2 view is more detailed than a level 1 view, as an example. Okay. So an example, like I said, you could have like add customer or something like that, or if you're in a library, check out book, something. That would be a process. Now the flow on page 182, the diagram basically is pretty simple. You just draw an arrow. I mean, whoopee. There's not much drawing involved in this guy, but it does matter which way the arrowheads are pointing. And they talk about how it's very likely that a process is going to have both an input and an output. 99.4% chance that all these processes are going to have at least one arrow going in and at least one arrow going out. Otherwise, they wouldn't be doing much, right? Okay. And they have some examples of done right, and they have some examples of done wrong. And the done wrong has some really cool names, so we'll talk about that for a minute. They talk about spontaneous generation. I love that. And that's where you have a process that has no input but produces output. So in their little diagram, they have a little process symbol, and they have arrows pointing in both directions coming out of it. And you might think, well, that's possible. You could have a process that generates data. Well, not in this world. In this world, that's another thing. That's called an entity. But so processes are kind of by definition don't spontaneously generate anything. So if you have everything coming out and nothing coming in, that's spontaneous, so you got something wrong. Now the opposite is a black hole, where all the arrows go in. In other words, this process is being fed data or other processes or whatever it is, and nothing's coming out of this thing, so it's a black hole. And so I just thought those names were kind of cool. And then the third one, of course, is what they call a gray hole, which basically means ain't no way you're going to produce that output based upon this input. And the example they have in their diagram is pretty cool. Like, you're generating the grade point average, and they feed it the date of birth, and that's supposed to generate your grade point average. Like, no. So anyway, learn from the bad examples, and it'll help you with your good examples. The next one at the bottom of page 183 is the data store symbol. And data store symbol basically is just a rectangle. Sometimes they have a little line on it. In some diagramming tools, it's kind of open end, so it kind of looks like an open end box. And this is essentially a database element. And we're not going to get into details yet of exactly what kind of database element that is. But it's supposed to represent some sort of thing where either you temporarily or permanently store some data. So it represents data that the system stores somehow. And it doesn't actually show the detailed contents of the data store, its structure, is it a table, is it a row, or is it an entire database? That's not for this level. And essentially, one of the rules is data stores have to be connected via the processes, the rounded corner guys. So for example, you can't have a user talk directly to a database. In fact, that would be horrible in the real world. You don't ever want your user to talk directly to the database. Obviously, you want to have some sort of logic in between, some sort of application, some sort of process where all their data gets filtered through and only the good data gets stored, not junk that gets entered. Okay, so far it's pretty straightforward. We got processes, that's kind of simple. We got data flow with the little arrows, that's no big deal. The data store basically just means either permanent or temporary storage of data, and that's pretty easy concept. The next one is what they call an entity. Sometimes they call it an external entity. What that basically means is, to put it in other words, these are things outside the scope of the project I'm doing. Now, a good example of something that's outside the scope is a human. For example, you're doing a library thing, and a customer walks up to the desk and says, I'm here to return these books. Well, that customer isn't under direct control of your system, unless, of course, you're some sort of mad scientist and you've got mind control built into your application. So that person is an external entity, and we don't control the external entities. What we do is we deal with them, and typically external entities will have data coming from them or to them, but they always go to a process. Okay. So there's a completed example on page 184 of essentially a bunch of data flow diagrams, starting with process symbols, with data flow symbols, and then the data store symbols. And I mentioned to you what the rules are, so let's just kind of go through them again, because once again, they show good ones and bad ones. And it's actually easier to look at the diagram and pick out the bad ones, because it's just easier to deal with. Number one is databases, or data stores, don't talk directly to the data stores. So they have to have an intervening process to happen. And so typically, you don't have a process that only writes to a data store. It would be like, what was the point? If you write to a data store but don't ever read the data, then why are you even doing it? And the other one is you rarely have a scenario where it only reads from a data store. Now, if you're a database person, you're probably thinking, well, yeah, but I got static tables. That's not what they're talking about. That's way, way down in the weeds. What they're talking about here is we're doing a logical model of a system. And while you're doing the logical model of the system, you are not going to have a data store only providing read access. Now, in reality, once you build the thing, you probably have lots of read access and no writes. But not at this point. At this point, we're talking about diagramming things at the high level. Okay. So this external entity has some rules. We've kind of mentioned that. Shows how the system interfaces with the outside world. And they're also called terminators because that's the boundary of my deal. And you can be an information source, meaning there's going to be an arrow coming out of the entity, or you could be an information sink, where the arrow is pointing the other direction. So this user is going to get a report, for example, and then walk off with it, and not use it ever again. So that's how the entity part works. Okay, so once again, they're showing some examples, some completed examples. The correct ones with the entities, and then the wrong ones with the entities. And again, an entity doesn't talk to an entity. I mean, come on, in real world, sure, customers talk to each other. That's not what we're talking about. We're talking about in the guise of this logical modeling. Entities don't talk to entities directly. They always go through a process. And entities do not talk to databases. Okay, cool. All right. And on page 186 is kind of a summary of what we just said. It shows a diagram of the, things that can talk to each other and things that cannot talk to each other. Okay, on page 186 they talk about the guidelines for drawing one of these things. So, whoop, that was the wrong one. So here is a example that we're going to use as we go through. So here are the rules. And some of the rules are going to be a little difficult to follow. One is draw the context diagram. That's what this is. See, this grading system. This is the entire thing that we're writing. This grading system, the center of this square, is the entire project. So this is what's called a context diagram. It basically, behind the scenes, there's going to be lots and lots of things going on. But you actually start with your entire project being one box in the center. Got it? Okay. So you draw this context diagram, and hopefully it'll all fit on one page. If you're drawing something that has that many things going on, okay. But hopefully it'll all fit. Try to find unique names for each one of the symbols so you don't get confused. And then, if you can, this is the tough part, try not to have the arrows cross each other, because that gets a little confusing. Okay, and that's basically the kind of the best practices for drawing one of these things. And we're coming up to the 15-minute mark, so we'll pick this up again in just a few.